Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to solve Cambridge exam May-June 2022, paper 41. Let's start it. Question 1. Answer questions using these substances from the list. Each substance may be used once, more than once, or not used at all. Which substance is a reactant in photosynthesis? Photosynthesis is a process in which the plant uses the sunlight to react carbon dioxide and water and produce oxygen and energy in the form of glucose. So one of the reactant is carbon dioxide. Which one is the main constituent of bauxite? Bauxite is the ore of aluminium, so it is aluminium oxide. The two products of fermentation in which we use yeast to ferment glucose produce ethanol and carbon dioxide. Which one is used as a fuel? Here we have ethanol, which can be used as a fuel. A gas used to convert iron into steel. This gas is oxygen. It is used in the basic oxygen process to convert iron into steel. A greenhouse gas, we have carbon dioxide and methane. Here from the list only we have carbon dioxide. A gas which is approximately 78% of clean dry air, of course it's nitrogen, a form of carbon. Here we have diamond. We have two forms of carbon, graphite and diamond. Here in the list there is diamond, so your answer will be diamond. Question 2. Atoms are made of protons, neutrons, and electrons. Atoms of the same elements are known as isotopes. Complete the table to give the relative charge and the relative mass of electron, neutron, and proton. The charge of electron -1, neutron has no charge, so it's 0. Proton has a charge of +1, and the mass of neutron is 1, mass of the proton is 1. Here we have two isotopes of magnesium, magnesium 1225 and magnesium 1224. Complete the table to show number of electrons, neutrons, and protons in these two isotopes of magnesium. This number 12 is a proton number, so it is the number of protons in the atom of magnesium. So in both isotopes, number of proton will be 12. And because it's an atom, so the number of protons equal to the number of electrons. We will have 12 electrons and 12 protons. Then to calculate the number of neutron, we will subtract the nucleon number, which is the number of proton and neutron, minus the protons. So 25 minus 12 will give us 13 neutron. And for the first isotope, 24 minus 12 will give us 12 neutrons. Explain why magnesium ion have the charge of +2. Magnesium has 12 protons. The electronic distribution of the atom of magnesium is 2, 8, 2, total of 12 electrons. To reach to a stable configuration of the nearest noble gas and to have 8 electrons in the outer shell, magnesium loses these 2 electrons. Now the ion of magnesium has electronic configuration of 2, 8. So the number of protons will be 12 and number of electrons will be 10. And that's why magnesium has a +2 charge, because magnesium ion have 2 more protons than electrons. Magnesium ion have the electronic structure of 2,8. Give the formula of the following particles which have the same electronic structure of magnesium. So we need another cation, which is positive ion, have the same structure of 2,8. Positive ion means it has lost one electron or more. So we will search for element in group 1 or group 3, because magnesium is in group 2. So we will search in group 3 and group 1, because these groups are metals. They form positive ions by losing electrons. So we will search for element in group 1 which can lose 1 electron to reach to total of 10 electrons. This element will be sodium. because sodium has 11 electrons. When losing 1 electron, it will be 10 electron, and the configuration will be 2,8. The element from group 3 will be aluminium, which has 13 electrons. After losing these 3 electrons, it will be total of 10 electrons distributed as 2,8. And then we will go for anion, negative ion, which has the same electronic configuration, which is 2,8. We will search for element that can accept 1 electron to be 10. So we will search for element which has 9 electrons that can accept 1 electron to be 10, which is fluorine. Fluorine is 2,7. It will gain 1 electron, then the fluoride ion will have the configuration of 2,8. Another element which can accept 2 electrons, like oxygen. Oxygen has a total of 8 electrons. It will accept 2 electrons to get a total of 10, and it will form a negative ion of -2 because it gained 2 electrons. So the oxygen ion will be also 2,8. This is also for nitrogen. Nitrogen in group 5. So it needs 3 electrons, total 7 electrons with nitrogen distributed as 2,5. So it needs 3 more to reach to the same electronic configuration of magnesium. It will gain 3 electrons and change from 2,5 into 2,8. This is the electronic configuration of the nitride ion. Then we want an atom which have the same electronic configuration like the magnesium ion, 2,8, which is named the nearest noble gas to magnesium. It has 10 electrons in total 10 electrons distributed as 2,8. Then question 3. This question is about sodium and compounds of sodium. Describe the bonding in the metallic elements such as sodium. You may include diagram as a part of your answer. As we can see, all metallic elements like sodium have positive ions regularly arranged and surrounded by a sea of delocalized electrons. So the description for the metallic bonding in sodium will be regular array of positive ions surrounded by a sea of delocalized electrons and held by the electrostatic force of attraction between the positive ions and the negative electrons. Describe how solid sodium conducts electricity. Sodium is a metal, so it will conduct electricity due to the presence of free moving or the free delocalized electrons. Here we have some properties of sodium chloride. It has high melting point. It cannot conduct electricity when solid, conduct electricity when molten, and it is soluble in water. Name the type of bonding in sodium chloride. Of course, it's ionic bonding, formed between metal, which is sodium, and chloride, which is non-metal. Explain why sodium chloride conducts electricity only when it is molten, because when it is in a molten state, the ions are free to move. So due to the presence of the free moving ions. But of course, when it is solid, the ions are fixed in their position in the lattice and they cannot move. Here we have an experiment. Student determine the concentration of solution of dilute sulfuric acid by titration using aqueous sodium hydroxide. Here are the steps of the titration. We are using 25 centimeter cube of 0.2 mole sodium hydroxide in a conical flask. The indicator is methyl orange and the purette is filled with sulfuric acid. We will add the acid from the purette until the indicator changes the color. The titration is repeated several times until a suitable number of results is obtained. First, name the piece of apparatus used to measure exactly 25 centimeter cube of sodium hydroxide. If he mentioned exactly, so we have to use pipette that can measure exactly 25 centimeter cube. State the color change of methyl orange indicator in step 4. methyl orange, first we put it in the flask with the sodium hydroxide. So color of methyl orange is yellow in alkaline medium. The starting color here will be yellow. After reaching to the end point, the color of methyl orange in neutral solution is orange. So we have color change from yellow to orange. State how the student decide that a suitable number of results have been obtained. He can decide if he obtained 2 or more results which are consistent. Consistent means very close to each other. That means that he is precise. So in titration, to be precise, to get consistent results, it has to be within 0.2 centimeter cube. So if the student gets 2 or more results within 0.2 centimeter cube, he knows that he obtained a suitable number of results. Here we have 20 centimeter cube of sulfuric acid react with 25 centimeter cube of 0.2 mole of sodium hydroxide. The equation as shown. First, we have to know the ratio between number of moles of sulfuric acid and sodium hydroxide. As we can see, the ratio is 1 to 2. So for every 2 moles of sodium hydroxide, only 1 mole of sulfuric acid is reacted. Calculate the concentration of sulfuric acid using the following steps. First, we will calculate number of moles of the 25 centimeter cube sodium hydroxide. The first step is to convert the volume into decimeter cube by dividing it by 1000. So the number of moles is the volume multiplied by the concentration. So it will be 0.005 moles. Then we have to determine the number of moles of sulfuric acid. As we can see here from the ratio is 1 to 2. So number of moles of sulfuric acid is half that of sodium hydroxide. We will divide it by 2. The number of moles of sulfuric acid will be 0.0025 moles. Then we will calculate the concentration of sulfuric acid. We have this formula, number of moles equal to the concentration multiplied by volume. The volume of sulfuric acid is 20 divided 1000 to convert it in decimeter cube, and the number of moles as we get it from the previous step is 0.0025, so the concentration will be 0.125 mole per decimeter cube. Question 4. This question is about compound of sulfur. Sulfuric acid is manufactured using contact process, and this manufacture involves 4 stages. First, molten sulfur burns in air to produce sulfur dioxide. Then sulfur dioxide reacts with oxygen to produce sulfur trioxide. Then sulfur trioxide combined with sulfuric acid to form oleum, and he gave you the formula of oleum. Then oleum react to form concentrated sulfuric acid again. Write the chemical equation for the reaction in stage 1. Sulfur burn in air to produce sulfur dioxide. So we have this equation, sulfur plus oxygen to give sulfur dioxide. Then state the essential conditions that are necessary for stage 2, which is the reaction of sulfur dioxide with oxygen to give sulfur trioxide. This is the basic reaction in the contact process, and this reaction is reversible reaction, so don't forget to draw the reversible arrows. Sulfur dioxide react with oxygen to produce sulfur trioxide, and the condition for contact process is 450 degrees Celsius. The pressure is 1 to 2 atmosphere, and the catalyst is vanadium pentaoxide. Write a chemical equation for the reaction in stage 3, in which sulfur trioxide react with sulfuric acid to form oleum. Here is sulfur trioxide and sulfuric acid, and he already gave you the formula for oleum, but you have to know it. Name the substance that react with oleum in stage 4. Oleum react with water to form concentrated sulfuric acid. So the substance that react with oleum is water. Hydrogen sulfide has a formula of H2S. Complete the dot and cross diagram to show the electronic arrangement in one molecule of hydrogen sulfide. Here you need to show only the outer shell electrons. Hydrogen can form one single bond, so it will form, each hydrogen atom will form one bond with sulfur, and sulfur is in group 6, so it has two lone pairs of electrons. You have to draw these lone pairs. So now this question is for 2 marks. 1 mark for the 2 bonding pairs of electrons. Here's 1 and here is the second. This is the 2 bonding pairs, and the second mark will be for the 2 lone pairs of sulfur, which are this one and this one. Balance the chemical equation for the reaction of hydrogen sulfide with sulfur dioxide. Here we have 2 oxygens, so we will multiply here by 2 to get 2 oxygen. Now we have 4 hydrogens, so we will multiply here by 4, also we get 4 hydrogens, and 2 oxygen, 2 oxygen. How many sulfur atoms? 2 multiplied by 1 is 2, plus 1, 3, so we have to multiply here also by 3. This is the balancing of the equation. Question 5. Ethanoic acid is manufactured by a reaction of methanol with carbon monoxide. An equilibrium mixture is produced. Here is methanol plus carbon monoxide, and the product is ethanoic acid. The equation at equilibrium, so we have to mention 2 characteristics of the equilibrium: that the rate of the forward reaction equal to the rate of backward reaction, and at equilibrium the concentration of the reactant and the product are constant. The purpose of the industrial process is to produce high yield of ethanoic acid at high rate of reaction. The manufacture of ethanoic acid is carried at a temperature of 300, and the forward reaction, which is the right side reaction, is exothermic. Use the information to state why the manufacture is not carried at a temperature below 300 or above 300. First, the forward reaction is exothermic, so the formation of ethanoic acid, the right hand side, is exothermic. It favors low temperature, but at a temperature below 300 the reaction will be too slow. If we increase the temperature above 300, as he mentioned, the reaction is exothermic, so increasing the temperature will favor the endothermic reaction, and the equilibrium will be shifted backward to the left side, decreasing the yield of ethanoic acid. So the yield of ethanoic acid will be low at a temperature above 300, because if increasing temperature in exothermic reaction, the equilibrium will be shifted backward to the left side. Complete the table using the words increase or decrease or no change. We have to know we have to write the effect of catalyst on the rate of reaction, rate of forward reaction. Of course, catalyst will increase the rate of forward reaction, but effect on the yield of ethanoic acid, catalyst has no effect on the yield. Decreasing pressure. How to know the effect of decreasing pressure? The reactant and the product are all gases, so if I increase the pressure, the reaction will be shifted to the side with a higher number of moles. So decreasing the pressure shifted the equilibrium to the side of higher number of moles, to backward to the left side, and that's the rate of the forward reaction will decrease, and of course the yield of ethanoic acid will decrease, because by decreasing pressure the equilibrium will be shifted to the side of higher number of moles. Here we have 2 moles and on the right side only 1 mole, so the reaction will be shifted to the left side, and that's of course will decrease the yield of ethanoic acid. Suggest which one of the following metals will be suitable to use as a catalyst, and give reason for your answer. We have aluminium, calcium. Aluminium is in group 3, calcium in group 2, magnesium is in group 2, potassium is in group 1, and cobalt, which is one of the transition metals. So we will use cobalt as a catalyst because we know that transition metals, one of the chemical properties of the transition metal is they can be used as catalyst. So the reason that cobalt is a transition metal. Ethanoic acid is a member of homologous series of carboxylic acid. State the general formula of this series. The formula of all carboxylic acid, organic acids, are CnH2n plus 1 COOH. Here we want to draw the structure of the carboxylic acid containing 3 carbon atoms. Show all atoms and all bonds. Remember, when you are drawing carboxylic acid containing 3 carbon, that the carboxylic group, the carbon in the carboxylic group, consider carbon number 1, then this one is carbon number 2, this one is carbon number 3. Then we will add the hydrogen atom to complete 4 bonds around each carbon. And don't forget that you have to show all bonds, all the bonds, even the bond between oxygen and hydrogen. When carboxylic acid react with alcohol, esters are produced. Here is the formula of ester. Name the ester X. So to name the ester, we will divide it into 2 parts. Here is the part that come from the acid. We have carb 1, 2, 3, 4 carbon. So this is butanoic acid. And here is the parts of the alcohol. It's only 1 carbon. So this alcohol is methanol. And the name of the ester will be methyl butanoate because it comes from butanoic acid. Name the carboxylic acid and the alcohol that react to produce this ester. Of course, butanoic acid and methanol. Here, calculating the empirical formula of ester, which has the composition of 48.65% carbon, 8.11% hydrogen, and 43.24% oxygen. The first step is to get the number of moles by dividing each one by the atomic mass. So we will divide the percentage of carbon by 12, then percentage of hydrogen by 1, and the percentage of oxygen by 16. So we will get these numbers, which are the number of moles. Then we will divide them by the smallest number, which is here 2.7. Dividing 4.05 by 2.7, we will get 1.5. Then dividing 8.11 by 2.7, we will get 3. And here, of course, we will get 1. Then we have to make this ratio as whole number ratio. So we will multiply by 2 to get rid of this decimal. So 1.5 by 2 is 3. 3 by 2 is 6. And 1 by 2 is 2. So the number of carbon atom would be 3, and hydrogen 6, oxygen is 2, and the formula will be, empirical formula will be C3H6O2. An ester Z has the empirical formula of C2H4O, and the relative molecular mass is 88. Determine the molecular formula of Z. So here we know that the molecular mass is 88. So first we will calculate the mass of the empirical formula. Here we have 2 carbons, 12 multiplied by 2, then 4 hydrogen, 4 multiplied by 1 is 4, and 1 oxygen, which is 16. So the mass of the empirical formula will be 44. Then the formula is the molecular formula mass equal to N multiplied by the mass of the empirical formula. So 88 equal to N multiplied by 44. That means that N equal to 2. The molecular formula is double the empirical formula. So the molecular formula will be double this, C4H8O2, because it will be double the empirical formula. Then question 6. This question is about zinc and its compounds. Zinc is extracted from its ore, which is mainly zinc sulfide. The steps of the extraction is as follows. The zinc sulfide converted first into zinc oxide. Then the zinc oxide is reduced in the furnace to give zinc, which becomes a gas. Then in step 3, the zinc gas is cooled to form molten zinc. Name the ore of zinc, which is mainly zinc sulfide. Zinc sulfide is called zinc blende. So the name of the ore is zinc blende. Describe how zinc sulfide is converted into zinc oxide. In step 1, zinc sulfide react with oxygen or heated in oxygen, or we can say zinc sulfide is roasted in air or heated in air to convert into zinc oxide. Name the reducing agent in step 2. To reduce zinc oxide into zinc, we are using carbon. Explain why zinc forms a gas in step 2 inside the furnace. Inside the furnace, the temperature is very high, above the temperature of the boiling point of zinc. That's why the zinc produces in a gas form. State the name of the physical change when zinc gas is converted into molten. Gas converted into molten means a liquid. From gas to liquid, the physical change is called condensation. Zinc sulfate crystal with 7 H2O are hydrated crystals. The zinc sulfate crystals are made by reacting zinc carbonate with dilute sulfuric acid, and the equation for the reaction, as you can see, zinc sulfate, sulfuric acid, and water, it will give zinc sulfate hydrated crystals and carbon dioxide. We are using large pieces of solid zinc carbonate added to the sulfuric acid. Then we have to make sure that excess zinc carbonate is separated from the aqueous zinc sulfate solution. Zinc sulfate is heated until a saturated solution is formed, and the saturated solution is allowed to cool for the formation of crystals, and then the crystals are removed and dried. So in step 1, zinc carbonate is in excess when no more zinc carbonate dissolve in sulfuric acid. State another observation that indicates that the zinc carbonate is in excess. So we are reacting zinc carbonate with sulfuric acid until no more zinc carbonate is dissolved, and the other observation will be no more fizzing or effervescence of carbon dioxide. That means no more reaction. All sulfuric acid is used up, and now zinc carbonate is in excess. So the other observation that there is no more effervescence or fizzing. Name a different substance other than zinc carbonate that can be added to dilute sulfuric acid to produce aqueous zinc sulfate. Also, zinc oxide, which is or zinc hydroxide, can react with sulfuric acid to produce zinc sulfate. Step 1 is repeated using powdered zinc carbonate instead of large pieces. All other conditions are kept the same, and the rate of reaction increases. Give a reason why the rate of reaction increases and explain your answer in terms of particles. When we grind zinc carbonate to produce powder, the powder has a larger surface area than the big lumps, so we have a higher area available to react, more collisions per unit time, and hence increase the rate of reaction. Suggest what is observed when the solution is saturated in step 3. Here, step 3, the aqueous zinc sulfate is heated until saturated solution, so here we can make the test for crystallization point in which crystals are formed on the glass rod. The formula of zinc sulfate crystals is, as you can see, with 7 H2O, 7 molecules of water. Give the formula of the solid formed if the crystals are heated to dryness. If the crystals are heated to dryness, it will lose all the water of crystallization, so the formula will be just zinc sulfate without any water of crystallization. Question 7. The periodic table can be used to classify elements. Group 1 element react with cold water to form alkaline solution. Here are group 1 elements. Put them in order according to the most reactive here on the left side and the least reactive here. We know that elements of group 1 increase in reactivity as we go down the group. So starting one, which is lithium, is the least reactive. So we will start here from lithium, sodium, potassium. As we go this side, on the left side, we are going to increase the reactivity until reach to cesium, which is the most reactive. Name the alkaline solution formed when cesium react with cold water. All elements of group 1 react with cold water to produce alkaline solution. So cesium will form cesium hydroxide when react with water. Group 1 element have lower melting point than transition metals. Describe one other difference in the physical properties of group 1 than the transition metals. Also, group 1 metals are soft and they have lower density than the transition elements. Group 7 elements are known as halogens. One of the halogen, astatine, is below iodine in group 7. So predict the physical state of astatine at room temperature and pressure. For group 7, the trend of the physical state starts from fluorine, which is a gas, then chlorine is a gas. After that, bromine is a liquid, iodine is a solid, then astatine is below iodine, so it will be also solid. The physical state is solid for astatine, as we can detect from the physical the trend of the physical state in group 7. Some group 7 elements react with aqueous solution containing halide ions. This is a displacement reaction for group 7 elements. When aqueous chlorine is added to aqueous potassium bromide, a reaction occurs. The ionic half equation is as shown. Here, chlorine reacts with potassium bromide. The equation, as you can see, here is chlorine and potassium bromide. Chlorine is more reactive than bromine, so it will displace bromine from its salt. Now we have the products, which are potassium chloride, because chlorine displaces bromine, and bromine will be displaced. So the color will change from the potassium bromide, which is colorless, to bromine solution, which is orange. So the original color of potassium bromide, colorless, and the final color of the reaction mixture will be orange due to presence of bromine. Identify the species that is oxidized and explain your answer. Here we will go back to the equation. Oxidation means loss of electrons. So bromide ions loses electron to form bromine. That's why bromide ions is a species that oxidize, because it loses electrons. Bromine monochloride is made by the reaction between bromine and chlorine. The chemical equation is as shown, and here we have the bond energy in bromine, Br, and in chlorine the bond between two chlorine atoms, and the bond energy between bromine and chlorine. We want to calculate the overall energy change for the reaction using bond energies from the table. So we will first calculate the energy required to break the bonds. So between Br and Cl and Cl, which is 190 plus 242. The total energy needed to break the bond is 432 kilojoule. Then the amount of energy released when the bonds are formed. Here we have two bonds between Br and Cl, so we will multiply this number by 2. 218 by 2 will be 436. And the overall energy change is the energy released from making new bonds minus the energy needed to break the bonds. So here we have 436 minus 432. The overall energy change is minus 4 kilojoule per mole. Here we come to the end of our exam. Like the video and subscribe to the channel to receive all the updates. Comment down below if you have any question. Thank you for watching. Wish you all best of luck.